So in this unit, we're going to learn a skill that's actually going to be used quite a bit in grade 11 and grade 12. Right? By itself, the skill isn't very useful. Like, it doesn't have a lot of applications. But when you use it to do other things, that's when it has other applications. So basically what we're going to do in this unit is we're going to learn a skill called factoring. And there's different types of factoring that we're going to learn. And if you want to see success in grade 11 and 12, you want to have very strong factoring skills, because we're going to be using it in different units in grade 11. We're going to be using it in different units in grade 12. So it's a really important skill. Okay. Before we start with the first type and what factoring is, okay, I just want to review a few algebra words. You don't have to know the definition of these. You just have to know when I say the word polynomial, you should know what I'm talking about. Okay? When I say the word binomial, you should know what I'm talking about. So a polynomial is an algebraic expression made up of one term or the sum of two or more terms with, and this is very important, whole number exponents. Okay? We've been dealing with these. I mean, we dealt with them a lot last year. We learned all sorts of different ways how to simplify polynomials. So like a polynomial, it could be made up of, when I say terms, a term is a variable, maybe with an exponent, a number, or a product of the two. So like a term could be like x. And that's also called the variable. We could put an exponent on it, x to the fifth. Okay. A number, well, you guys know what a number is, 4. Or we could put the two together by multiplication, 4x to the fifth. All of those are terms. When we have one term or more than one term, we call it a polynomial. So like a polynomial could be something like, 4x to the fifth plus x to the fourth minus 2x to the third plus 7. This one's made up of 4 terms, because terms are separated by addition and subtraction signs. Okay? And this term has a number and a variable with an exponent getting multiplied. This number just has a variable with an exponent. This is a variable with an exponent times a number. This is just a number. Okay? The exponents have to be whole numbers. If you saw fractions here, remember we took fraction exponents, not a polynomial. We don't do work with it. We don't factor with it. If it's negative, we don't do work with it. We don't factor with it. So refreshing your memory on polynomial, can somebody tell me what a monomial would be? Yep. A one-term polynomial. So it could be like 4x to the 5th. Nothing is added, nothing is subtracted after it. It's just there by itself. Binomial? Yeah. Two-term, and I'll just put little quote marks for ditto. It means the same as above. So it would be like 4x to the 5th, and then let's add something else, x to the 4th. And you can probably see the pattern that trinomial would be three-term polynomial. So it'd be like 4x to the 5th plus x to the 4th minus 2x to the 3rd would be an example. You especially want to know what I mean when I talk about binomials and trinomials, because we're going to be using those words a lot. Okay, what's this whole factoring thing? Well, you guys have been factoring since junior school. Like if I asked you, if I said, what are the factors of 6? What would you say? What would you tell me? 6. Why is 6 a factor of 6? Because 6 goes into it one time. So 6 times 1 are factors, right? Are there any other factors? 2 and 3, right? Because 2 times 3 is 6. So arithmetic with numbers only, no variables, no algebra. When we take a number and we break it up into 2 or more numbers getting multiplied together to get that number, we have factored it. So if I were to ask you to say factor 24, well, I want to break it up into 2 or more numbers that multiply to get 24. There's all sorts of answers, isn't there? Okay. I mean, it could be 3 times 8. And actually, you know what? I'm not even going to use this table. I'm just going to take it out. So it could be 3 times 8, or could be 4 times 6, or 2 times 12. Or this time, give me 3 numbers. Give me 3 numbers that multiply to get 24. 3 times 4 times 2. Okay. And there's more. I mean, I could have asked you for, give me 4 numbers that multiply. So that's what we do when we factor something. We break it up into, if we factor a number, we break it up into 1 or more numbers that multiply to get that number. If we factor an expression, so let's say I want to factor 5x plus 10. In these situations, there's only one answer. I want to think of 2 expressions that when I multiply them together, I get 5x plus 10. I could multiply those 2 expressions together. Because you guys know how to multiply. 5 times x plus 2 in parentheses, this binomial, is 5x plus 10. Okay? I mean, you guys have been doing the multiplying since last year and reviewing it this year. Now we're going backwards. Now we're taking an answer and we're saying, okay, what multiplies to get that answer? That's the whole idea of factoring. And it helps us solve many types of problems that we will see later on. I could factor something like this. x squared plus 5x plus 6. Meaning I want to break those up into two expressions that multiply to get this. Well, it turns out that it's going to be x plus 2 times x plus 3. And you guys know how to multiply these. We did them before. We'll review them this year. When you have a binomial times a binomial, you have to do 4 multiplications. So if you multiply all this out, x squared plus 3x plus 2x plus 6, and simplify it, you get this. Just like if you multiply 5 times x plus 2, you get what we started with. So the question is, like, how do we go from here to here? Like, how did I know these? Well, it depends on what the expression is. That's why there's different types of factoring. Okay? We are going to talk about the first one, like the first example, 5x plus 10 we did. Okay? And this method is called factoring out the GCF. Remember what GCF stands for? Greatest common factor. Greatest common factor. So here's how we do it. Let's take this one. We're going to factor 5x plus 10. Break it up into two expressions that multiply to get 5x plus 10. First of all, we want to find the greatest common factor of 5x and 10. What is the largest expression that goes into 5x and 10? What number goes into both of them? 10 does not go into 5. 5 goes into both of them, right? Can I divide an x into both of them? No, because there's no x here. Okay, so the greatest common factor of these two is 5. This is one of the factors. Okay, this is a factor. How do we find the other factor? How did I find the one in parentheses? Well, we take the original, 5x plus 10, and we divide by the GCF. What's 5x divide 5? X plus 10 divide 5. 2. And I need to keep those together. And what do I use to keep things together in math? Parentheses. This is the other factor. These are the two factors that multiply to get this. So your final answer, you got to show the multiplication. You got to take the first factor, which is the GCF, and times it by the second factor, which is x plus 2. That's your final answer. Okay, let's just practice finding the GCF first, and then we'll start factoring a few of them, because you need to be comfortable finding the GCF first. So let's look at these. And they get progressively more complicated. But you'll start to see a pattern that will help you find the GCF quite easily. 10x and 15. 3? 5. What about any? Can I Put x's into both of them? No, because there's not an x here. So 5. We'll just pretend we didn't hear that. Okay, now this one, 12a squared and 18a. Elsie? 6 for sure. 6a. Because can't I divide an a into both of them? Like there's 2 a's getting multiplied here. There's 1 a getting multiplied here. So this a has to be part of the GCF. Could a squared go into both of them? No, because there's not enough here. So that's the GCF. So follow that pattern and see if you can do this one. Remember, if it doesn't have an exponent, assume it's 1. What do you think this one would be? Well, what's the greatest common factor of the numbers? 4. M squared is the most number of m's I could take out of each one. Anything else? A single n. I can't take more than one n because there's only one here. Good, you guys are getting it. This one. 7. I heard it whispered, p to the third. Q to the third. Way to go, Ayla. Yes, that's super. Okay, so now that we're familiar with that, let's start factoring a few. So remember, and you guys are going to get to the point where you're not going to have to show any work for this. You're going to be able to get to the answer right away. The GCF is one factor, and then we got to divide to find the other factor. And then we put those two factors together by multiplication. So we've got the greatest common factor. Remember, F stands for factor. So what's the GCF? 3. How do I find the other factor? Take the original, all the terms, and divide them all by 3. What do you get? 2n plus 3. Remember, you got to divide all of them by 3. So that means that this times this, these multiplied together, is my answer. And that's exactly what factoring is. Getting a little better? Okay. This time I'm not even going to write these words. 2c, which means the other factor, I have to take every term in the original and divide by 2c. So you got to know your division. 6c divide 2c, 3, and remember it's going to be parentheses, minus 4c squared divide 2c, 2c. Put the two factors you found together by multiplication. So 2c times 3 minus 2c. Here's the beautiful thing about factoring. How can you check to see if your answer worked? How can you check to see if you did it right? Yeah, just multiply it out, see if you get back here. If you do, you've done it. You must have done it correctly. Okay. Here we've got 3 terms, otherwise known as a trinomial. What's the GCF of all 3? Just 5. I can't take any z's because there's not a z in the first term. How do I find the other factor? Well, I got to do 3 divisions. Be careful here. 5 divide 5. Whoa. 1. 5 minus 5 is nothing. Minus 10z divide 5. 2z. Plus 5z squared divide 5. Z squared. And remember, that second factor is always going to go in parentheses. Put the two factors you found together by multiplication, and that's your factored answer. Okay. What's different about this last one? Yeah, it's a negative at the beginning. Okay. Whenever the first term is negative, the GCF has to be negative. Okay. So that means GCF must be negative. So you got to be careful with that. So our GCF automatically, because the first term is negative, and now just look at everything else and see what the GCF is. What do we got? 4. Remember, this x here is the same as x to the first. I can take an x out at maximum. Y squared. Good. Second factor is found by doing negative 12x to the third y to the third plus 20 xy squared minus 16 x squared y squared. All of that divided by the GCF, which is negative 4xy squared. And that answer is going to be in parentheses. That's our second factor. So we're not going to see too many of these. Generally, we factor 2 or 3 terms, a binomial or a trinomial, and the exponents and variables don't get too crazy. All right, so you got to know your division. This one divide this one. What do we get? Positive 3 x squared, and then y. Good. 3x squared y. Is the next going to be plus or minus? Minus. Yep. Just 5. No. Because this divide this is 1. This divide this is 1, and negative 5 times 1 times 1 is just negative 5. Positive or negative? Positive, and it's going to be 4x. Good. Now remember, you're not done yet. You've got to show the actual factoring answer is putting the two factors together you found by multiplication. That is your final answer. Okay? That's one type of factoring. Remember that, GCF factoring. We're going to talk about 3 other main types that we use that help us solve problems. But that's it for now.